example problem number 2. If a battery contains 0.355 grams of cadmium and excess nickel oxide hydroxide, how long can it operate if it draws 1.25 milliamps of current? And you're given the balanced redox reaction below. Alright, so because this question mentions current and how long, there's only one equation that deals with that. That's N is equal to IT over F. We know that I is amps, so that's going to be 0.00125 amps. And we know Faraday's constant already. 96,500 coulombs per mole of electrons. The question is asking us to solve for time, so T is going to be equal to N times F over I. Alright, so all we need is N. Remember that N is the mole of electrons that is determined stoichiometrically. So let's go ahead and get it. You are told that you have an excess amount of the nickel precursor. So the 0.355 grams cadmium is going to be our limiting reactant here. So 0.355 grams of cadmium times 1 mole of cadmium divided by 112.41 grams. Now, that's going to be equal to 0.00316 moles of cadmium, solid. The redox reaction is right here. That's cadmium 0 going to cadmium hydroxide. And in this reaction, cadmium is 2 plus. So for cadmium to go to cadmium 2 plus, it's got to give up 2 electrons. So my mole to mole ratio of the electrons to cadmium is a 2-to-1 ratio. So 0.00316 moles of cadmium times 2 moles of electrons for every 1 mole of cadmium. That's going to give me the value of N, which is 0.00632 moles. And when all is said and done, you should get a time of 487904 seconds, everybody, which is approximately 136 hours. That's an awfully nice lifetime for a battery to operate, everybody. 136 hours. And if you look at these elements, it's nickel cadmium, so I'm sure you've heard of batteries that are called nickel cadmium or cadmium nickel batteries, which are very nice batteries that help to power devices such as your smartphones and cameras. Alright, so that's our lecture, everybody, from Electrochemistry. I want to thank you for your time, and I'll see you next time on Educator.com.